Hi guys, tonight we're imagining something truly bizarre. What if the vacuum of space suddenly developed its own weather systems? We're talking about clouds forming in space itself, storms of dark matter, and atmospheric phenomena where there should be nothing but void. If you enjoy these cosmic weather sleep stories that reimagine the nature of space, hit that like button and subscribe for more. And drop a comment letting me know what time it is where you are and where you're listening from. I enjoy connecting with space enthusiasts everywhere. Alright, let's begin. The morning sky above New York City ripples like water disturbed by an invisible hand. Office workers streaming across Brooklyn Bridge pause mid-stride as the familiar blue dome overhead begins to shimmer with patterns that shouldn't exist. What appears to be clouds are forming in the vacuum of space itself, 62 miles above Earth's surface, where the atmosphere gives way to the infinite black. These aren't ordinary clouds composed of water vapor and ice crystals, but something entirely alien. Condensed dark matter swirling in currents of exotic particles, following laws of physics that would make Einstein weep. Welcome to a reality where space itself has developed its own meteorological system, where the vacuum between worlds churns with storms that dwarf any hurricane Earth has ever witnessed. This is a universe where the concept of weather extends far beyond our thin atmospheric envelope, where cosmic forces generate precipitation measured not in inches of rainfall, but in showers of antimatter particles and gravitational waves that can be felt across light years of distance. In this transformed cosmos, the International Space Station, orbiting at an altitude of 254 miles, has become humanity's first extraterrestrial weather observatory. Commander Sarah Chen floats before a viewport that once offered an unobstructed view of the star-filled void, now watching as massive formations of what scientists have termed quantum cumulus drift past like cosmic icebergs. These structures, composed of condensed space-time itself, stretch across distances that would encompass entire solar systems. The largest formation currently tracked by NASA extends 14 billion miles from edge to edge, containing enough warped space-time to alter the orbital mechanics of planets within a radius of 200 astronomical units. The genesis of space weather began 3 years ago, when deep space monitoring stations detected the first anomalous readings. Temperature fluctuations in the cosmic microwave background radiation, previously uniform at 2.7 Kelvin across the observable universe, began showing variations of up to 15 degrees. Regions of space that had maintained absolute zero for 13.8 billion years suddenly registered thermal signatures equivalent to summer afternoons in Death Valley. The European Space Agency's Planck telescope array, positioned at the second Lagrange point, recorded the formation of the first spatial pressure system 93 million miles from Earth, where solar wind particles began accumulating in patterns reminiscent of terrestrial low-pressure zones. Dr. Maria Volkov, the lead theoretical physicist at CERN, discovered that these phenomena stemmed from what she termed vacuum phase transitions. The quantum foam that exists at the smaller scales of reality had somehow achieved macroscopic coherence, allowing the zero-point energy fluctuations that normally cancel each other out to amplify into measurable effects. Her calculations, published in Nature Physics, demonstrated that regions of space containing dark matter concentrations above 47 particles per cubic centimeter could sustain stable thermodynamic gradients, effectively creating atmospheric conditions in the vacuum itself. The implications became staggeringly apparent when the first space hurricane formed in the asteroid belt between Mars and Jupiter. This cosmic cyclone, spinning at rotational velocities approaching 12,000 miles per hour, generated gravitational eddies powerful enough to alter the trajectories of asteroids weighing billions of tons. The European Space Agency's robotic probe Cassiopeia, investigating the outer edges of the phenomenon, transmitted data showing wind speeds of exotic particles reaching 43,000 miles per hour before losing contact entirely. Recovery missions launched 6 months later found the probe's titanium hull twisted into impossible geometric shapes, transformed by exposure to space-time currents that operated according to non-Euclidean principles. Earth's response to these cosmic weather patterns proved both fascinating and terrifying. The planet's magnetosphere, normally a stable protective barrier deflecting solar radiation, began fluctuating wildly as space storms passed through the solar system. Aurora displays appeared at latitudes where they had never been observed before, with residents of Mexico City and Cairo witnessing ethereal light shows typically reserved for Arctic regions. The KP index, measuring geomagnetic disturbances, registered values exceeding 9 on a scale previously thought to max out at 9, forcing scientists to recalibrate their instruments to accommodate readings that peaked at 17 during the worst cosmic tempests. Agricultural regions worldwide began experiencing what climatologists termed gravitational seasons. The slight variations in Earth's gravitational field caused by passing space weather systems affected crop growth in measurable ways. Wheat yields in Kansas increased by 23% during periods of gravitational compression, while regions experiencing gravitational rarefaction saw plant growth stunted by up to 38%. The US Department of Agriculture established a new division dedicated to gravitational farming, developing predictive models that allowed farmers to time their planting cycles according to forecasted space weather patterns. The economic implications reached into every sector of human activity. Global shipping routes, dependent on GPS satellites for navigation, faced constant disruption as gravitational lensing effects caused by space storms bent radio signals in unpredictable directions. Container ships found themselves hundreds of miles off course, with the ever-given equivalent of 14 container vessels running aground simultaneously when a particularly severe gravitational depression passed through Earth's orbital vicinity. Lloyd's of London estimated maritime losses at $87 billion in the first year alone, leading to the development of new insurance categories covering acts of cosmic weather. Airlines confronted even more dramatic challenges as their aircraft, climbing to cruising altitudes of 35,000 feet, encountered the lower boundaries of space weather phenomena. Flight BA237 from London to Singapore became the first commercial aircraft to experience space-time turbulence when it entered a pocket of compressed vacuum at 41,000 feet. Passengers described the sensation as riding an elevator that suddenly accelerated to 3 times the speed of sound, while simultaneously moving backward through time. The flight crew's chronometers showed they'd gained 14 minutes during the 6-minute turbulence event, a temporal displacement that forced aviation authorities to develop new protocols for schedule management. NASA's weather prediction capabilities underwent revolutionary expansion as the agency established the Solar System Meteorological Service. Traditional satellite-based weather monitoring proved inadequate for tracking phenomena that could span multiple planets, leading to the deployment of an early warning network extending from Mercury's orbit to the Kuiper Belt. The service's headquarters, relocated from Houston to a specially constructed facility in orbit around Earth's L1 Lagrange point, employs 237 meteorologists specializing in disciplines that didn't exist before space weather emerged. These cosmic forecasters track pressure systems measured in units of warped space-time, precipitation events consisting of dark matter droplets, and temperature gradients spanning 17 orders of magnitude. The first space tornado, detected forming in the outer regions of the Oort cloud, measured 800 billion miles in diameter at its base, with a vortex extending inward toward the inner solar system at velocities approaching 1% the speed of light. the phenomenon's approach triggered the first ever solar system emergency declaration, with all spacecraft beyond Jupiter's orbit ordered to seek shelter behind planetary bodies or evacuate to Earth's protective magnetosphere. The Voyager probes, humanity's most distant ambassadors launched in 1977, transmitted their final coherent signals as they were consumed by the tornado's outer bands, their last data packets describing encounters with fragments of space-time itself moving at relativistic speeds. Mars became an inadvertent laboratory for understanding space weather's effects on planetary evolution. The red planet's thin atmosphere, already vulnerable to solar wind erosion, began experiencing accelerated atmospheric loss when exposed to space storms carrying exotic particles. The Martian atmosphere, containing approximately 25 teratons of carbon dioxide, lost nearly 40 billion tons of gas during a single severe space weather event that lasted 18 Earth days. Paradoxically, the same storm deposited roughly 62 billion tons of dark matter particles on the planet's surface, creating regions where gravitational fields fluctuated by up to 12% from their baseline values. Scientists working with the Mars Sample Return mission discovered that rocks exposed to space weather developed unique crystalline structures impossible to replicate in terrestrial laboratories. These formations, dubbed cosmic crystals, exhibited properties that seemed to violate conservation of energy, generating minute amounts of electricity through processes that appear to tap directly into quantum vacuum fluctuations. The implications for energy production proved revolutionary, leading to the construction of the first vacuum energy harvesting stations in Earth's upper atmosphere, where space weather phenomena provided the most accessible source of harvestable quantum effects. The European Southern Observatory's Very Large Telescope, perched high in Chile's Atacama Desert, captured the first detailed images of space weather systems extending across interstellar distances. These cosmic storm fronts, visible through their gravitational lensing effects on background starlight, revealed organizational structures spanning hundreds of light years. The Milky Way's spiral arm showed evidence of persistent space weather patterns that had been shaping galactic evolution for millions of years, suggesting that what Earth was experiencing represented just the local manifestation of a galaxy-wide meteorological system. Astronomers studying the Andromeda Galaxy detected similar phenomena occurring on even grander scales, with space storms stretching across multiple galactic clusters and generating pressure waves in the cosmic web itself. These observations led to the disturbing realization that space weather might be connected to dark energy, the mysterious force driving the universe's accelerating expansion. Dr. Raj Patel's team at the Atacama Large Millimeter Array calculated that if space weather systems continued growing in intensity at their current rate of 7% annually, they could begin affecting the fundamental constants of physics within local regions of space-time. The biological effects of space weather on Earth's ecosystems proved both subtle and profound. Marine biologists discovered that whale migration patterns had shifted dramatically, with humpback whales altering their traditional routes by an average of 300 miles to follow gravitational gradients created by passing space storms. The whales appeared to use these gravitational currents as underwater highways, reducing their energy expenditure during long migrations by swimming in regions where space-time curvature provided a form of gravitational assistance. Bird migration presented even more dramatic adaptations. The European robin population developed an enhanced sensitivity to gravitational fields, with their traditional magnetic navigation system supplemented by what ornithologists termed gravitational compass behavior. Flocks of migrating birds began following curved flight paths that corresponded exactly to the gravitational field lines generated by overhead space weather systems, suggesting rapid evolutionary adaptation to cosmic environmental changes occurring within generational timescales. Deep ocean ecosystems experienced unexpected flourishing as space weather penetrated Earth's crust through gravitational effects. Hydrothermal vents along the mid-Atlantic ridge showed increased activity during periods of gravitational compression, supporting expanded communities of extremophile organisms. The biomass of tube worms around these vents increased by an average of 44% during space storm seasons, while new species appeared with metabolic processes seemingly adapted to variations in local gravitational fields. The psychological effects on human populations proved equally noteworthy. Psychiatric hospitals reported 32% increases in admissions during severe space weather events, with patients describing symptoms of temporal displacement and gravitational vertigo. Dr. Elena Rodriguez, leading a study at Johns Hopkins Hospital, documented cases where individuals appeared to develop prescient abilities during space storms, accurately predicting events up to 6 hours before they occurred. Her research suggested that human consciousness might be more sensitive to space-time disturbances than previously imagined, with certain individuals acting as biological early warning systems for cosmic weather changes. Educational systems worldwide underwent rapid transformation as space weather became an integral part of daily life. Elementary schools in Finland pioneered curricula teaching children to read cosmic weather maps alongside traditional atmospheric forecasts. Students learned to identify the characteristic signatures of approaching gravitational fronts, understanding how cosmic pressure systems would affect everything from playground activities to homework assignments. Universities established new departments of cosmic meteorology, with MIT's program becoming the first to offer doctoral degrees in space-time dynamics and applied gravitational engineering. The agricultural revolution triggered by space weather extended beyond simple gravitational effects on plant growth. Farmers discovered that certain crops exposed to exotic particle precipitation developed enhanced nutritional properties, with tomatoes grown during dark matter showers containing 47% higher levels of antioxidants. Wine producers in the Bordeaux region found that grapes harvested during specific space weather conditions produced vintages with unprecedented complexity, leading to the establishment of cosmic vintage classifications commanding premium prices in international markets. Space weather's influence on technology development accelerated innovation in ways that paralleled the early days of aviation. Engineers developed gravitational shielding systems for sensitive electronic equipment, using controlled fields of exotic matter to create stable zones unaffected by cosmic storms. These shields, initially protecting scientific instruments, found applications in data centers and hospitals, where gravitational fluctuations could cause catastrophic equipment failures. The first commercial space weather modification experiment occurred when a consortium of Japanese companies attempted to dissipate a minor cosmic depression threatening to disrupt satellite communications. Using a fleet of robotic spacecraft deployed at strategic points around the storm system, they released controlled bursts of antimatter designed to destabilize the phenomenon's internal dynamics. The experiment succeeded beyond expectations, completely dispersing the storm within 48 hours and proving that humans could potentially exert some control over cosmic weather patterns. This success led to international debates about space weather modification ethics and territorial claims in regions of altered space-time. The United Nations established the Committee on Cosmic Weather Governance, tasked with developing frameworks for managing human interventions in space weather systems. Early discussions revealed fundamental disagreements about whether nations could claim sovereignty over modified regions of space-time, particularly when such modifications affected gravitational fields extending across multiple countries' airspace. Religious communities grappled with theological implications as space weather challenged traditional concepts of divine creation and natural law. Vatican astronomers published treatises exploring whether space weather represented a previously unknown aspect of divine creation or evidence of fundamental changes in the structure of reality itself. Buddhist monasteries in Tibet reported that meditation practices performed during space storms produced enhanced states of consciousness, with practitioners describing experiences of perceiving the interconnected nature of space-time itself. Indigenous communities, particularly those with strong astronomical traditions, often adapted most readily to space weather realities. Inuit elders in northern Canada incorporated space weather observations into traditional knowledge systems, developing terminology for cosmic phenomena that paralleled their extensive vocabulary for describing terrestrial weather conditions. Aboriginal Australians found correlations between space weather patterns and traditional songlines, suggesting that ancient oral traditions might have preserved knowledge of cosmic phenomena that modern science was only beginning to understand. The medical implications of space weather exposure became a major research focus as human populations adapted to living within an active cosmic meteorological system. Hospitals near the boundaries of frequently active space weather zones reported unusual healing rates, with bone fractures healing 23% faster during periods of gravitational compression. Conversely, surgery performed during gravitational rarefaction events showed increased complication rates, leading to the development of medical space weather advisories for scheduling elective procedures. Insurance companies faced unprecedented challenges in assessing risks associated with space weather damage. Traditional actuarial models proved inadequate for calculating premiums covering gravitational damage to buildings, temporal displacement of cargo shipments, and the psychological treatment cost for space weather-related anxiety disorders. Lloyd's of London established specialised space weather underwriting departments, employing teams of cosmic meteorologists to assess risk factors for policies covering everything from satellite launches to concert tours that might be affected by gravitational anomalies. The energy sector underwent revolutionary changes as companies learned to harness space weather phenomena for power generation. Quantum vacuum power plants, constructed at high altitudes where space weather effects were strongest, achieved efficiency rates that made traditional fossil fuels economically obsolete. These facilities, generating electricity by tapping into the enhanced quantum fluctuations created by space storms, produced energy at cost below 2 cents per kilowatt hour while producing zero emissions. Space weather's effects on human reproduction sparked intensive medical research, when fertility clinics reported 28% higher success rates for in vitro fertilization procedures performed during certain cosmic weather conditions. Dr. Sarah Kim's longitudinal study at Stanford Medical Center documented that children conceived during space storms showed enhanced mathematical abilities and increased sensitivity to electromagnetic fields. These findings led to speculation about accelerated human evolution in response to cosmic environmental pressures. The tourism industry adapted by creating space weather viewing destinations, with hotels in locations offering optimal viewing of cosmic aurora displays and gravitational light shows booking months in advance. Iceland's position at high latitudes made it a prime destination for space weather tourism, with the country's gross domestic product increasing by 18% as visitors flocked to witness cosmic storms from Earth's surface. Specialized tour guides trained in cosmic meteorology led expeditions to remote locations where space weather effects were most dramatically visible. Commercial fishing operations discovered that certain fish species exhibited behavioral changes that correlated precisely with space weather patterns. Tuna populations migrated along paths that followed gravitational field lines, while deep-sea creatures previously unknown to science appeared in fishing nets during severe cosmic storms. These organisms, adapted to life in regions of altered spacetime, possessed biological structures that seemed impossible according to traditional understanding of physics and biology. Transportation networks required complete overhaul as space weather became a permanent factor in logistics planning. Shipping companies developed new route optimization algorithms that factored in gravitational headwinds and tailwinds created by cosmic weather systems. Railroad companies discovered that trains achieved 12% better fuel efficiency when traveling in the same direction as gravitational currents, leading to dynamic scheduling systems that adjusted departure times based on space weather forecasts. The communications industry faced constant adaptation challenges as space weather interfered with satellite operations and terrestrial networks in unpredictable ways. Cell phone towers required gravitational stabilization systems to maintain signal integrity during cosmic storms, while internet infrastructure companies invested billions in hardened fiber optic networks resistant to space-time disturbances. Paradoxically, some space weather phenomena enhanced communication capabilities, with gravitational lensing effects occasionally providing natural signal amplification for radio transmissions. Financial markets developed new trading instruments based on space weather predictions, with commodity futures contracts for vacuum energy and gravitational stability certificates becoming major trading categories. The Chicago Mercantile Exchange established the first cosmic weather derivatives market, allowing businesses to hedge against space storm-related losses while providing opportunities for speculative trading based on cosmic meteorological forecasts. Educational institutions pioneered distance learning technologies adapted to space weather conditions, with universities developing classroom systems that remained functional during gravitational fluctuations. Students learned to study in environments where the passage of time varied slightly from room to room, developing cognitive flexibility that prepared them for careers in a space weather-affected world. Scientific research accelerated as space weather provided natural laboratories for testing theoretical physics concepts. The Large Hadron Collider achieved breakthrough discoveries by timing particle collision experiments to coincide with cosmic weather events that enhanced quantum effects. Research teams discovered new fundamental particles that existed only within regions of altered spacetime, expanding the standard model of particle physics to include cosmic weather-dependent phenomena. Archaeological investigations revealed that space weather had affected Earth throughout geological history, with sediment cores showing periodic deposits of exotic particles corresponding to ancient cosmic storm events. These findings suggested that space weather played a role in mass extinction events and evolutionary leaps, providing new frameworks for understanding biological and geological history. As humanity adapts to life within an active cosmic meteorological system, the fundamental nature of reality continues revealing new layers of complexity and wonder. Space weather represents not merely an environmental challenge to overcome, but a window into the dynamic, interconnected nature of existence itself, where the boundary between Earth and cosmos dissolves into a unified system of perpetual change and magnificent possibility.